All right, so we are going to look at a linear relationship in a graph this time. So the last video I made was a linear relationship in a table. So if you haven't watched that one, go back and take a look at it. It was a pretty short video if I remember correctly. It's just analyzing the table version of this same idea. So we're going to look at a graph. So this one, we're going to determine the rate of change on a graph. So we can look at the rate of change in y over the change in x, which is exactly what we did with the table. And we can do that right on the graph. Or we can write a list of coordinates and determine the change as we did with the table. So first we're going to look at the graph. If they give us the graph, it's pretty darn easy. We're just going to look at the change in y. How much do we move up or down to go to the next point? So if I look at this point here and I want to go, how much am I moving up to go from this point to the next line where this one lands? So I'm going up 1, and from this one I'm going up 1. So I'm not looking at from the bottom how far up did I go. I'm saying from one point to the next I had to go up 1, and then if I'm at this point I have to go up 1 more to get to the next point, and then if there was another point I'd have to go up 1, and we can see it's crossing right here. So I'm going up 1 time. Change in x, that has to do with moving right or left. So how much do we move left or right to go to the next point? So this one I can see if I'm looking at this one I have to move to the right 1, and then if I wanted to go to the next one I'd have to move another right 1. If I wanted to go that other one that we looked at here I'd have to go another right 1. So I'm moving to the right 1. So with this one my constant rate of change would be 1 over 1, which we could just write as 1. We wouldn't actually have to write the fraction there, but they'll have us write it as a statement, which I'll show you on the next page. So this is just the basic idea of how to find it. So we can look at that exact same problem, but we're going to look at the coordinates. So now I'm going to look at these coordinates. So I have 0, 0 for my first one. The next one I have 1, 1. And my next one I have 2, 2. So I can see my 3 coordinates here. My change in y, on this one I'm looking at what is it changing by each time. To go from 0 to 1, I added 1. To go from 1 to 2, I added 1. Sorry, this is my change in x. That was silly of me. So this is x column. It always goes x then y. That is why they are called ordered pairs. They are in order. Okay, so it always goes x's and then y's. So now I'm going to look at my change in y. And in this case, that goof, if I had to put it over here, wouldn't have mattered because they're both 1s. But definitely be careful about that because you usually have different numbers there. So it'd be 1 over 1. So either way I'm looking at this, I'm just looking at how much is it changing, how much am I moving up or down from one point to the next, how much am I moving right or left from one point to the next. All right, so let's go ahead and look at how Alex is going to present this to us. So we have each graph below shows a relationship between x and y. For each graph, determine whether x and y are proportional. If x and y are proportional, fill in the blank with a number. So with this one, the main thing to notice here is that I'm not starting at 0, so this immediately is going to be not proportional. And if we think about that, if I look at this point, so this looks like maybe 1.5 over here, and I'd have to go up 2 on this one. So to get to this line, I'm going from 0 to 2. Well, if I tried to do that same thing for this one, I'd have to go up 2 and maybe over half, because it's going from 1 to like 1.5 to 2, so it's really only like a half move. So I'm going up 2 and over half. Well, if I go up 2 and over half, I do land on the correct points here. So it does look somewhat proportional if you look at those points. But because we're not starting at 0, it's not going to work out perfectly with the change. So if I look at the change here from point to point, if I go up, I'd have to go up from 2 to 6, and that's 4 moves, and then this is 1. So it'd go up 4 and 2, so it's not always going to be exactly, 4 and 1. It's not going to be perfectly proportional if you don't start from 0. This is called a direct variation, which we'll actually practice a little bit more on some of the next videos. But a big part of this is, does it start at 0, 0? If not, immediately it's not going to be proportional. All right, the next one, I accidentally clicked too many times here. So you can already see I accidentally clicked on proportional. I need to animate that. But I'm looking at what's my rise. So I'm going up. It's starting at 0, 0. I'm going up 2. And then from here, I'm going up another 2 to get to that next line. So I'm going up 2 each time. So you can see my change in y is 2. And then my change in x, if I'm starting here at 0, I have to go over 1 to get to this point. And I have to go over another 1 to get to this point. So each time I'm going up 2 over 1. So there's my change. I'm going up 2 over 1. So I can see y is how many times x? Well, it's 2 and x is 1. So it's 2 times x. So with this one, if you can reduce this down to a 1 for x, then that'll tell you what your multiplier is for y. All right, so that is a linear relationship in a graph. I hope that helped, and I'll see you on the next video.